Now the next is basically the concept of distance between parallel lines. Now first we saw the distance between uh, point and a line. Now the next concept is distance between parallel lines. So this and this sort of, right? And let's say you have an equation of, okay, let's just take the generic type as well. Zero, and because there are parallel lines, so sort of x and y will be in a similar shape as we had discussed before as well. Plus d equal to 0, or c1 c2 you can call it, doesn't really matter. So the distance between parallel lines would be c minus d, again absolute value, distance cannot be negative, root over a square plus b square. Why? Because a square, like a and b are same between these two equations, right? So for example, if we were to take two parallel lines as 3x plus 4y plus 7 equal to 0 and 3x plus 4y minus 10 equal to 0, so the distance would have been 7 and 10 differ by 17. So 17 over root over 3 square plus 4 square, which is 25. So which is 17 by 5 would have been the distance. And you're done. The only variety of this could be, and again, since this was again a modulus, right? So distance should not be negative. The only variety of this could be like, okay, if you have this line of 3x plus 4y plus 7 equal to 0, let's keep this first line the same, and second line is, let's say, uh, like whatever, minus 15x uh, minus 20y plus 14 equal to 0. What is the distance between these two lines? So it's easy to figure out, right, that, okay, this is 3 and 4. Even this we can change to a similar form of 3 and 4, right? So this will be, again, if we change this, if we divide by minus 5, so this will be 3x plus 4y minus 14 by 5 equal to 0. Now we know that these are parallel. So again, the same concept works. So 7, c will minus g, 7 minus of minus 14 plus 14 by 5. So this is 7 plus 14 by 5 root over 3 square plus 4 square, which is 5 only. So 35 is 49 by 25 is the answer. The So like you should definitely get used to like whenever you see the equation of the line set, even before like moving ahead in the question, you should definitely be sure that, okay, these two I can spot are parallel lines. These two I can spot are perpendicular lines. For example, let's say you have an equation of 2x plus 3y equal to 7, and the equation of minus 2x plus minus 3x plus 2y equal to 11. Should immediately notice, like before starting on the question, that irrespective of what 7, 11, or like what the numbers are, here the slope is minus 2 by 3, here the slope is 3 by 2, product is minus 1, the lines are perpendicular. Right, that should be the first catch from the question. The second catch would be that basically if the lines are parallel, you should be able to spot that as well, that okay, these lines are parallel. Like some of the times it is very obvious, as we saw, right? Like 3x plus 4 by 3x plus 4 by, you would know. But other times you may have to reduce it into a form where like dividing by a constant number or multiplying with the same number would make it parallel. So you have to bring it into that form, and then. So for applying this formula, it is very, very necessary that the first and the foremost step is to ensure that those lines, like those coefficients, are same. Because if you see that the coefficients are only a and b, right? So if you had to find the distance between these two lines, you would have to mandatorily convert these into similar formats. Like 3x plus 4y plus k, 3x plus 4y plus k2. To essentially say that the a and b for the two equations should be the same. So if you feel that it is not the same, then you need to reduce it, and then only apply this. There is no way to apply this directly on these two equations. So first you have to make it into these two equations, and then you have to apply this. Okay, cool. So distance between distance between parallel lines and perpendicular distance from point to a line are two important concepts that you should know, and like you should also know, like as we discussed, right, that what needs to be done before applying those formulas. For the perpendicular from point to a line, as we saw, that the uh, distance would be a modulus. So if directly distance needs to be found out, then it doesn't matter. But if the reverse is to be found out, you know how to do the process now. There'll be multiple cases for the 5 and the minus 5 and etc. For here, it is more straightforward. Cool. So now the next point, and it's a separate like subtopic in itself, so which is called the section formula. So if you see, like till now, whatever we have discussed is mostly around like, okay, what is the slope, what are different distances, etc., etc., right? But we have never like talked about division of a line into a certain ratio. So for example, like we talked about midpoint, but midpoint is like a simple formula, just like x1 plus x2 by 2 and stuff. But if the same ratio was, let's say, 3 is to 4 or something, right? So if p is x1 y1, q is x2 y2, you need to find a point which divides this line in ratio of 3 is to 4, or in general m is to n. Let's say this point is x, or let's say this point is a. So we need to figure out this point, and that is where the section formula helps. So there are two parts to it. One is we see that there is a line PQ and this A lies on PQ, like lies between PQ. So it divides the line internally. So there's an internal section formula and there's an external section formula. In this case, the point A is between P and Q, which means it divides the line internally into this ratio of MS to N. So going by the internal section formula, or section formula for internal division, you can call it. So for A, the coordinates will be, the x coordinate will be, you do a crisscross. So m into x2 plus n into x1 upon m1 plus n2. Y coordinate similar, you do crisscross, m into y2, n into y1 over m1 plus m2. These will be the coordinates for the internal section formula for the point A. Right. For the external section formula, and we'll see a couple of applications here as well. External section formula means that the point divides the line from outside. So here basically if we write this in form of an equation, so what we were saying is AP by AQ was M by N. This is what it says essentially, right? External is basically you have the same 2 points P and Q, x1, y1, x2, y2. But here the division is external, which means the third point, or the point A, lies outside of this line segment. So let's say it lies somewhere here. And basically the thing here is that it divides, again the same division is done, AP by AQ only. So AP is this, AQ is this. So basically this entire thing, let's say this entire thing is M, and this entire thing is N. So again, AP by AQ is M is to N still. The equation doesn't change, but yeah, the way it divides changes. So we say that the point A divides PQ externally in the ratio of M is to N. The coordinates of A would then be, again you do a crisscross. So basically you have the first ratio with the point P is M, and this with the second point is N. So you again do a crisscross. So it will be mx2. Here it will be a minus instead of a plus, minus nx1, like the ratio with the second point into the x coordinate of the first point with the crisscross, upon m1 or m minus n. So everything that was a plus here changed to a minus, and that's the only difference. Comma, same for y coordinate as well. So m y1, m y2 actually, m y2 minus n y1, because second to again the y coordinate of the first point, upon m minus n. These will be the coordinates for external division. Okay, so mx2 minus nx1, like this goes this side, this goes this side, upon m minus n, my2, so the first ratio into the second point coordinate minus the second ratio into the first point coordinate upon m minus n. So the same thing as here, just that the plus has changed to minus, and the diagram has changed basically. So this is the internal and the external section formula. Right. So now basically if you were given 2 points and you were supposed to like find a point A which divides that line into the ratio, let's say 2:5 or whatever, you can find that coordinate of the point, right? If you're given these 2 points. So that's the most basic application. But think about what we've covered before. If you remember, if we were covering triangles, right? We saw this concept of a Euler line, right? Which basically said that there's a thing called HGO, basically orthocenter, centroid, and circumcenter. Orthocentroid, circum. And we know that the HG is to OG was 2:1. The ratio we already knew. So essentially to say that if for a particular triangle, if I give you the coordinates of H, if I give you the coordinates either of G or O, you can find the third one. We know that the ratio is 2:1. Any two is given, you can find the third one. For example, let's just see if these two are given, then finding this is easy. This is just the direct section formula. If O and H are given, then you need to find the point in between those two. But if let's say this is given as, for example, okay, this let's say you have to find out. So this is for example HK. G is let's say given as 3, 4. O is let's say given as 5, -7. So you are asked to find what will be the coordinates of the orthocenter. Right. Given that these are the coordinates of the centroid and the circumcenter. So this will again check two concepts. That first you should know that it divides the HG by OG is divided in the ratio of 2:1. And the second you should know the section formula, how it is applied. So for example, if you were to apply it here, then G, which is the point in the middle, so the x coordinate of this will be nothing but, yeah, somebody has a question? Okay, the x coordinate of this will be nothing but 2 into x coordinate of this, which is 2 into 5, plus 1 into h, which is h, by 2 plus 1, 3, some of the ratios, right? So this basically tells me that 10 plus h equal to 9. So h I know now is -1. So I know that this is -1 comma k. We need to find k. K also similarly to just writing it here. So basically we know that this point is 4. So crisscross 2 into -7, which is -14, plus 1 into k, which is k upon 3. So k will be equal to nothing but, this is 12 plus 14, so k will be equal to 26. So this is -1 comma 26 is your orthocenter coordinates. So basically, if any 2 points are given, you can find out the third point using section formula. Either section formula will be directly applied. If they are given H and O, it is the direct application. If they are given the centroid to you, then it will be like you have to use section formula, but like the variable would be one of these points itself, and you know this. Cool. Exactly similar application. Let's say you have a triangle here, and somebody says that okay, this is the median, this is the centroid, right? So you know that the median, like the centroid divides the medians into the ratio of 2:1. If I give you this point, you can find this point, right? For example, like a sample question could be, let's say you have this triangle is anything, let's say 4, 7, B is 3, 8. You have to find C, right? And you're given the coordinates of the centroid as let's say 3, 5 or whatever, right? Okay, it won't, this is not dimension, so let's just be 1, 8. So that like 1, 3, and 4 fall in the X pattern. So 3, 5 is a centroid, and you know this. And you're supposed to find out the third vertex, right? So if this is a centroid, the median will pass through this. We know that this would be a ratio 2:1. So if I, on this line, if I know 2 points, I can find out this point. Once I know this point, of this point, I know from the midpoint theorem that this point will nothing be this plus this by 2, comma this plus this by 2. I can find out C. Like hopefully it's clear, right? So you find the point like M, for example, here. So for example, like just for illustration's sake, M comes out to be 6, 9 or something. So C basically would then be, you will write that okay, if this is C is X and Y, so you would write that 1 plus x by 2 equal to 6 and 8 plus y by 2 equal to 9, and you will find the coordinates of this by midpoint formula. Why it is the midpoint? Because this was a median, so medians intersect the side at the midpoints. So very, very useful concept, the section formula. So please keep that in mind. Right. So that is that. Now, while we are on triangles, right? So let's just cover some of the coordinates of the triangles as well. So this is a triangle ABC. Centroid is G. The centroid of a triangle is basically x1 plus x2 plus x3 whole over 3. y1 plus y2 plus y3 whole over 3. Centroid is nothing but intersection point for median. So these are the coordinates of that. x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. Okay. And there is another point that we studied that is called the incenter, right? The incenter, as you would recall, is the meeting point of the angle bisectors. The coordinates of the incenter, and let this be x1, y1, just for proper labeling, x2, y2, x3, y3. So this side, the notation is small a, small b, small c. Incenter is nothing but a into x1. So you take the side into the opposite coordinate, a into x1 plus b into x2 plus c into x3 whole over a plus b plus c, comma a into y1, b into y2, c into y3 whole over a plus b plus c. This is the in center of the triangle. So easy to remember, like centroid is the simplest. Just sum the 3, divided by 3, you're done. For in center, just multiply the side with the opposite vertex and keep adding them. Divide by the sum of the sides basically, and you've gotten the coordinates of the in center. Cool. Okay. Now that we have this figure, we know the 3 vertices. What would be the area of this triangle? If we are only given the 3 vertices, area, of course, we have like discussed half a dozen formulas before as well. But since we had not touched on coordinate geometry, so we didn't discuss this formula there. But area of triangle is, again, it's a like once you get the pattern, you don't have to memorize it as well, right? So you start with x1 into y2 minus y3 plus x2 into, after y2 minus y3, what will come? y3 minus y1 plus x3 into, after y3 minus y1, what will come? y1 minus y2. So it's like a, if you imagine, it's like a circular thing, right? You start from y2 minus y3, then y3 minus y1, then y1 minus y2. All are getting added, x1, x2, x3. This is the area of the triangle. Once again, area is a positive number, so it's important to note that there will be a mod here. Why it's again important to note? Because if I give you 2 points here, let's say this point is, it's 3 comma 8 or something. This is 2 comma 6. Find the coordinate of the third point such that, and c, let's say again, lies on the x-axis or something, So basically it will be k comma 0. They'll give you some hint on the other point as well. So k comma 0. So basically what you need to figure out is like, what is the point c, such that the area of the triangle is 10 square units. Now, if you're in a hurry, right, what you would do is just, okay, basically, okay, I know the coordinates, I know the formula for the area, I'll just equate it to 10, get k, and I'm done. No, but you'll have to equate it to both 10 and minus 10, because it's again a modulus here. So there'll be 2 values of k. Because if you really see, right, if you try to like this is the mathematical aspect of it, right? But if you try to see if this is this line, right, and you're asked to find that, okay, what are the coordinates of the third point on the x-axis, which is like creates an area, a triangle of area 10. So you see that one could be this triangle. Similarly, there could be another triangle this side, such that both are same in area. So geometrically, it's visible that you would be having more than one scenario. So which is why you should remember that there is an absolute value sign for area as well. Cool. So this is area of a triangle, right? Now coming to quadrilateral. Let's say any quadrilateral you have, right? x1, y1, x2, y2, x3, y3, x4, y4. Now it may seem like quadrilateral being a four-sided one would be a more complex version of this, but not exactly. The formula for quadrilateral's area of quad, is nothing but a simple matrix basically, which says x1 minus x3, x2 minus x4, y1 minus y3, y2 minus y4. That's it. And a half outside. This is it. Now, you know how to open a matrix, right? So this into this minus this into this. Just cross multiply and subtract. This in x1 minus x3 into y2 minus y4 minus x2 minus x4 into y1 minus y3. And take the half of that, you're done. Right. So it's again not a complex formula as such. You can also find the area of a quadrilateral by dividing it into two triangles and then summing up, but like why do that long, right? For example, if for this quadrilateral you could have, if you didn't know this formula, what would you do? You would find the area of this triangle, you know the coordinates. You find the area of this triangle, you know the coordinates. You put both of those into these formula, calculate it twice, add them up to find the total area. Instead of that, you can just find the total area by the simple matrix of cross multiplication. Right. Now, very important, like important point here is to ensure that these vertices are taken in order. Right. Typically, what you would get is they will give you some points, right? Like 2 comma 3, minus 7 comma 8, 1 comma minus 5, 3 comma minus 10, etc. Right. Now, can you take any of them as x1, y1, x2, y2, x3, y3, x4, y4? No. You need to take them in a certain order. So which is why whenever they give you coordinates and they ask you to find something, it's always good to just have a mental picture of, or you can even draw it on a pen and paper as to in a coordinate system where those points would lie, right? And then you need to take them in an order. Once you have the order in place, then you can define x1, x2, x3, x4 in your preferred order. Like let's say if you have this quadrilateral, once you know that okay the 4 points fall here, you know what the quadrilateral looks like, then it's fine. Then you can like start with x1, like you can draw x1, x2 here, x1, y1 here, x2, y2 here, x3, y3 here, x4, y4 here. Or you can even do x1, y1 here, x2, y2 here, x3, y3 here, x4, y4 here. Or you can start from x1, y1 here. Then you can select the order in your own discretion. No problems at all. But you should not face a scenario where you're taking x1, y1 here and x2, y2 as a diagonally opposite side, because then they'll not be in order. So whenever the coordinates are given and sort of these questions sort of are asked that okay, that these coordinates are given and they may not mention that they are taken in order. If they mention it, then it's a direct formula, but they won't mention it typically because they want to test that in a hurry you may make a mistake of just taking in whatever order the question mentioned, and you'll find that and get the wrong answer. Right. So for you first need to ensure that okay, I have four sets of coordinates, what type of a quadrilateral they are forming on the plane. Then you can take any of these order. Then you can start from anywhere. You can go clockwise, anti-clockwise, doesn't really matter. But those four should be in some sequence. Shouldn't be like the first point is here, the second point is here. Cool. Okay. So that is one. So again, it's important to note some of these like disclaimers in addition to knowing the formula, right? Otherwise, because direct formulas like they won't obviously give, right? They won't give you the triangle, three vertices and ask you to calculate the area. Like this formula would definitely be used, but you have to do some work in order to get it to a stage where this can be directly applied. Okay, so area of triangle, area of quadrilaterals, we're done. So helpful to sort of sketch those in the Cartesian plane before starting the question. Now the sort of a very important aspect, but also the last part of the theory is the equations of lines. As we saw, the general equation is ax plus by plus c equal to 0, right? We saw the slope of this minus a pi b, right? If you were asked the y-intercept of this, right? So if any line is here, this is the x-intercept, this is the y-intercept. So for y-intercept, what is to be done? Just put x as 0. So the y-intercept of this line would be nothing but minus c by b. Just put x equal to 0, find y. The x-intercept of this would have been nothing but you put y equal to 0, so minus c by a. Okay, so for any line, you can find the x and the y intercepts, like if you're given the equation in this form, and this is typically how equations are given. Like if you, even like without studying coordinate geometry, right, you would have seen the equations of lines in this format only, like 90% of the time, right? So x and y intercepts can be figured out, right? And the quickest way to plot a line, right, if somebody tells you that okay, there's a line of 2x plus 3y plus 7 equal to 0, and you need to plot this on a graph, the quickest way is to just figure out what the x and the y intercept would be and then join those 2 points. So for the x-intercept of this line, the x-intercept would be where y equal to 0. So we'll be minus 7 by 2. So basically then we know that the x-intercept would be somewhere here, which is minus 7 by 2 comma 0. The y-intercept would be x equal to 0. So basically minus 7 by 3. So somewhere here, minus 0 comma minus 7 by 3. Just join these 2 points and you have the line. Like you extend this, you have this line. So the easiest way to and the quickest way to plot the line would be, because in practical questions you'll have to plot lines to in order to move ahead with the question at times. So the easiest way to do it would be just mark the intercepts and just join them. That's it. So this is the first and the foremost the most popular equation of a line, wherein you can derive those things. The second equation of the line is also something that you may have seen, which is y equal to mx plus c. M is the slope, c is the y-intercept. It is clear. If you put x equal to 0, you'll get y equal to c, right? So c is the y-intercept here. Like so these, like the equations are maybe the same, but the form of the equations is different depending on what you know about those lines. For example, if somebody gives you the slope of a line and a y-intercept, you can directly put it here. So if you are asked to find the equation of a line with a slope of 3 and a y-intercept of 5, you can directly say the equation would be y equal to 3x plus 5, right? So like these are different forms of equation of the same line, but it depends on what you are given and what you need to find out. The third is if you are given 2 points on the line, how to find that out? How to, like if you're given PQ, let's say 3, 5 and minus 4 comma 7 or something, what is the equation of the line joining them? We know 2 points, which means we can find the slope, right? So the equation of the line would be, you can take y minus y1 over x minus x1 equal to the slope. This should be the slope, right? Any general point on this line, if x comma y, so y minus y1 x minus x1 should be equal to y2 minus y1 over x2 minus x1. If you take an example, let's say you take this example itself. So 3, 5 and minus 4, 7. So a generic point on this line would be x comma y, right? So you would write the equation as y minus, let's say you can take any point, right? Because it's a line, the slope will be the same, does not really matter. So once again, I'm repeating, you can take any point. So let's say you take with respect to this, for example, right? So y minus 7, x minus or minus 4v plus 4 equal to the slope that you know. So 7 minus 5 is 2, minus 4 minus 3 is minus 7. You just like make this into a more consumable format and you're done. It's 2x plus 8. To say that 2x plus 7y minus 41 is the equation of your line, and you're done. So basically this is the 2-point form of a line where you are given 2 points. So essentially when we say that you're given 2 points, as we saw that you're given the slope of the line. So you can take a generic point on the line and then reference that to any of these points. Even if you took the 3, 5 point, it would have yielded the same answer. Okay, so this is another form. The other form is and again, like if you're just, so this is when you're given 2 points, this is when you're given slope and the y-intercept. If you're given a point and the slope, then it is even simpler. Then you can just say y minus y1 over x minus x1 will be that slope which is given. So if you're given that, okay, there's a line passing through 3, 5 and the slope is 2. So simple, you can take any general point on this line as xy. So y minus 5 over x minus 3 will be equal to 2. You just multiply this here and you get the equation of the line. So this is the point slope form of a line. Cool. So again, depends on what is given or what you know basically, like of whatever you have found out. So for example, if for a line you have found out the slope, okay, this should be the slope, and I know one point of this line, so immediately you should strike that it should be somewhere on these lines, right? So if you have a point of 3 comma 4, so just to again repeat this example, right, and you have a slope of -7, so y minus 4 upon x minus 3 will be -7. That's the equation. The last is when you're given just the intercepts. Like you're not given slope, you're not given anything else, you're not given the points, you're just given the, okay, there's a line which cuts an intercept of, let's say, 3 units on the x-axis and 5 units on the y-axis. So the equation of that line would be x by a plus y by b equal to 1, where x is the a is the x-intercept and b is the y-intercept. So if the intercept were like 3 and 5, so it will be x by 3 plus y by 5 equal to 1. Okay, so like these are not again like 5 different forms. If like a lot of them are pretty intuitive, right? Once you know that how the slope is generally formed, like y minus y upon x minus x. So these forms you don't even need to study them in different forms. Once you know a point and the slope, you can just easily figure out the equation of that. If you know 2 points, you can easily figure out. Because 2 points again would essentially mean that you know the slope. Right. If they give only the intercepts, then this is the form of the equation that is one. Cool. So this basically ends our theoretical discussion on coordinate geometry. Cool. So now we'll start with the questions, but like just to uh, take a 1 minute break for any questions, or if you guys have any scenarios that were not being covered or like anything that you need to confirm, happy to take a question. Cool. Okay. Let's then start with the questions. And again, from an exam standpoint, you don't need to know anything theoretically beyond what we've covered here.